Welcome to Orbital Log, January 17, 2026. Today, we explore a supernova that shouldn't exist, the surprising heat of early galaxy clusters, NASA's Artemis II preparations, and how lensed supernovae might solve the Hubble tension. Astronomers at Kyoto University observed SN 2020 ESA, a type IC-CSM supernova, challenging long-held assumptions that stars 30 times the mass of our Sun collapse silently into black holes. Using the CME telescope in Okayama for rapid classification and the Subaru telescope in Hawaii for high-sensitivity analysis a year later, researchers detected a stable one-month periodicity in the supernova's light curve. This pattern suggests the progenitor star experienced annual eruptions before its final explosion, indicating it was part of a binary system with a companion object. The findings suggest such systems evolve into black hole binaries, which are sources of gravitational waves detected by LIGO. Lead author Keiichi Maeda noted, "This provides a new direction to understand massive star evolution toward black hole binary formation." Astronomers using the Atacama Large Millimeter-Submillimeter Array detected the earliest hot galaxy cluster atmosphere ever observed in SPT 234956, when the universe was 1,400,000,000 years old. The intracluster gas, measured via the thermal Sunyaev-Zeldovich effect, showed temperatures exceeding those of many present-day clusters. This infant cluster, with a core size comparable to the Milky Way's halo, hosts over 30 starburst galaxies, forming stars at rates thousands of times faster than our galaxy. The discovery, led by University of British Columbia PhD candidate Daji Zhou, challenges existing models by revealing violent processes, like supermassive black hole outbursts, heated cluster atmospheres far earlier than previously assumed. This finding pushes the observational record back to the earliest direct detection of hot cluster gas, requiring a re-evaluation of how galaxy clusters evolved in the early universe. NASA is preparing for the Artemis II mission, targeting a launch between February and April 2024, with the crew launching at 9:41 p.m. Eastern Standard Time. The rollout of the Space Launch System rocket and Orion spacecraft to Launch Pad 39B at Kennedy Space Center is scheduled no earlier than January 17th. This journey will cover 6.5 kilometers, taking up to 12 hours. Engineers recently resolved a valve issue in the Orion capsule's hatch pressurization system, replacing it on January 5th after a countdown demonstration test detected the problem. They also fixed a leak in ground support hardware used for pressurizing Orion with oxygen gas. Final preparations include a wet dress rehearsal, fueling the rocket with 2,650,000 liters of cryogenic fuel, conducting a launch countdown, then safely unloading the fuel. The mission will last 10 days, marking humanity's first crewed mission beyond low Earth orbit in over 50 years. Researchers using the James Webb Space Telescope have identified two gravitationally lensed supernovae, SN Ares and SN Athena, which could help resolve the Hubble tension. SN Ares, exploded 4 billion years ago, is lensed by the MJ 0308 galaxy cluster, and its light will reappear in 60 years. SN Athena, which exploded 6.5 billion years ago, is lensed by MJ 0417, and will reappear in 2 to 3 years. The Hubble constant measured via cosmic microwave background yields 67 kilometers per second per megaparsec, while the cosmic distance ladder method gives 73 kilometers per second per megaparsec. These lensed supernovae provide a new method to measure the expansion rate with precise time delays between multiple images. The Venus survey, led by C.G. Fujimoto at the Space Telescope Science Institute, uses JWST to observe galaxy clusters for rare astronomical events. Connor Larison, a postdoctoral researcher in the Venus collaboration, noted the significance of these observations for understanding the universe's expansion. Thanks for joining us on Orbital Log. Tune in next week for more cosmic insights. We're your source for the latest in space science, delivered weekly.